In the first part of this question, we need to differentiate between adsorption and absorption. Both of them are distinct processes involving the interaction of the substances, but they differ fundamentally in their mechanisms. Adsorption is the process where the molecules or particles adhere to the surface of a solid or liquid. The substances stick to the surface of the adsorbent without penetrating to it, and it involves the surface interactions often through van der Waals forces or chemical bonds. For example, activated carbon adsorbing pollutants from air or water is a type of adsorption. Whereas absorption is the process where one substance is taken up and penetrates into the bulk of another substance. The absorbed substance enters to the interior of the absorbing material and they will result a uniform mixture throughout the volume. A sponge absorbing water is an example for absorption. And the second one is to differentiate between lyophobic and lyophilic salt. Both these terms are used to describe the affinity of a colloidal particles for dispersion medium. In case of lyophilic salt, the dispersed particles have a strong affinity for the dispersion medium, and these colloids are typically more stable because the strong interaction between the particles and the medium prevents the aggregation. At the same time, in case of lyophobic colloids, the dispersed particles have little to no affinity for the dispersion medium, and these colloids are less stable and can easily aggregate or precipitate out of the solution. They often require stabilizers to maintain the stability. And in the third one, we need to differentiate a multimolecular colloid and a macromolecular colloid. Multimolecular colloids consist of clusters of small molecules or atoms that aggregate into particles typically ranging from 1 to 100 nanometers in size. And these particles form when many small molecules or ions aggregate together due to the weak interactions such as van der Waals forces. Whereas in case of macromolecular colloids, it consists of large macromolecules or polymers which themselves form the colloidal particles. The particles are large single macromolecules or polymers that can be several nanometers to micrometers in size. In the old question, we need to define the given terms. The first one is zeta potential. Zeta potential is the electrical potential at the shear plane of a colloidal particle in a dispersion. It measures the magnitude of the electrical charge on the particle surface and is an important indicator of the colloidal stability. This is the difference in electrical potential between the dispersion medium and the surface of the dispersed particles measured at the shear plane where the particles interact with the surrounding liquid. A high zeta potential indicates a strong repulsive forces between the particles which helps to maintain the stability in the colloidal system by preventing the aggregation. And this is typically measured using the techniques such as electrophoretic light scattering or microelectrophoresis. And the second one is to define coagulation. Coagulation is typically involving the neutralization of the electrical charges on colloidal particles, which reduces the repulsive forces between them and allows them to clump together. This is often achieved by adding coagulants such as electrolytes or flocculants. And in the second question, we need to write the reason for why a negatively charged salt is obtained when silver nitrate solution is added to potassium iodide solution. Because when silver nitrate solution is adding to potassium iodide, the I- ions or iodide ions will be adsorbed to the surface of silver iodide colloid. This is the reason for the given statement. So in the first part, for each differentiation you will get 1 mark, and in the old question you will get 1 mark for each, that is to define zeta potential, coagulation and writing the reason for the formation of the given salt. So the total marks will be 3.